All right, welcome back to another episode of Math with Mr. Young. So today we're going to work with 5.5 factoring expressions. Our standard is 6th grade evaluating expressions A. Our objective is that we're going to be able to factor numerical and algebraic expressions. And our mathematical literacy, we have factoring and expression. Let's go ahead and get started. All right, so for 5.5 factoring expressions, our success criteria is that we're going to be able to use the distributive property to factor numerical expressions. We're also going to be able to identify the greatest common factor of terms, including variables, and also use the distributive property to factor algebraic expressions. And also we'll be able to interpret factored expressions in real life problems. All right, so for our mathematical literacy, and by that, I'm talking about our math vocabulary words. So we're going to factor expressions. Now, we're going to break this word apart, factoring expressions. But what it means is that we write a numerical or algebraic expression as a product of factors. You can use the distributive property to factor expressions. All right. So we just learned about the distributive property with 5.4. And just remember that all the lessons we do, they build upon each other. So factor, when we factor, factoring means that, or just the word factor, they are numbers that we multiply together to get another number. For an example, when we use multiplication, we have the factor 2 times the factor 3 to get the product 6, okay? So keep that in mind, what a factor is. Now, an expression has numbers, symbols, and operators such as addition, subtraction, multiplication, and division that are grouped together to show the value of something. So in this case, we have this expression, or in this case, it's since it has an equal sign, it's an equation, but we have the expression 4x minus 7. So in this case, I kind of messed up here. In this case, 4x is a term and 7's a term. So again, the only way we distinguish what terms are, they are separated by addition and subtraction operator signs. So only those two tell us what terms are. Okay, and of course, I guess this would technically count as a term as well. So we try to find what x equals to make this expression true. Now, when we use when we factor expressions, we're going to use, numbers. So numerical expressions, so numbers. So we can do like 3 times 7 plus 3 times 2. That would be 3 times 7 plus 2. Okay, so this is what we mean. So when we do 3 times 7, we're talking about that. And then 3 times 2, and then we're going to add those two together. Same thing here, algebraically. We can do it like where we have a times b plus a times c. That's going to equal a times b plus c. Okay. Another one I could give you is, let's see here. I don't know, let's try this one. 3 times 7 minus 3 times 2. So that's going to be 3 times 7 minus 2. So again, if you do that, 3 times 7, and then 3 times 2 is 6, and then of course subtract that. So that would be, as an algebraic expression, will be a times b minus a times c, and that's going to equal a times b minus c. So as long as you got this down, sorry, you didn't see that part. As long as you got this down, you should be good to go. All right, so we're going to go ahead and factor numerical expression. Just keep in mind that when you factor any expression, you can factor out any common factor. Okay, so the first one, let's call this A. Let's call this B. Now for A, it tells us to factor 18 plus 30 using the greatest common factor. Now, if you remember the greatest common factor that we worked on in, I believe, chapter 1, I suggest you watch that video and brush up on that, but I can show you right now as well. So when we're finding the greatest common factor of 18 and 30, we're going to go ahead and find factors of 18, and then factors of 30. So check this out. Now keep in mind, you're looking for factors. Again, factors are what you multiply together to get another number. So if we multiply 1 times 18, that equals 18. Let's see here. 2 times 9 also equals 18. Let's see here. 3 times 6 also equals 18. So again, you have 1, 2, 3, 6, 9, and 18. Those are all factors of 18. Factors of 30, you multiply 1 times itself. 1 times 30 equals 30. 2 times 15 equals 30. Let's see here. 3 times 10 also equals 30. And 5 times 6 equals 30. Now, I'm going to go ahead and circle all the common factors. Okay, so they have 1 in common. They have 2's in common, 3's in common, and 6 in common. So, out of all of those, ask yourself, which one do they have that is the greatest common factor, the greatest common factor, the GCF, the greatest common factor of 18 and 30 is going to equal 6, because 6 is greater than 3, 6 is greater than 2, and 6 is greater than 1. So keep in mind that we're going to be factoring the expression, the numerical expression 18 plus 30 using the greatest common factor. So we found the greatest common factor of 18 and 30, which is 6. Now check this out. So I'm going to rewrite this here, okay? So we circled all the common factors. I'm going to rewrite this using the greatest common factor. So we have 18 plus 30. Now, by using the greatest common factor, 6, so ask yourself this in your head. What can I multiply to 6? What can I multiply to 6 to equal 18? Well, 6 times 3 would equal 18. Also, same thing, 6 times 5 would equal 30. So 6 times 3 equals 18, and 6 times 5 equals 30, okay? So, and then from here, we rewrote the expression using the greatest common factor. Now we want to write it with the distributive property. So again, 6 is here, the greatest common factor. And look at this, so it's going to be 3 plus 5. So 3 plus 5, there you go. So there you go, my friends. You just factored a numerical expression using the greatest common factor. So if you were to distribute 6 times 3 equals 18. And same thing, 6 times 5 equals 30, and that makes that expression true. So these are equivalent numerical expressions here. Ultimately, this is what you have when you factored. All right, let's try that again. This time, I'm going to move this up just a little bit. So let's try this one now. So we have 20 minus 12. We're going to factor 20 minus 12 using their greatest common factors. So again, we're going to have factors of 20 and factors of 12. So again, keep in mind that we're going to look for the greatest common factor. We need to use the greatest common factor to factor these expressions. So let's see here. I do know that 1 times 20 equals 20. 2 times 10 equals 20. Let's see here. 4 times 5 also equals 20. So 4 times 5 equals 20. Now in factors of 12, 1 times itself. 1 times 12 equals 12. 2 times 6 equals 12. And 3 times 4 equals 12. Again, we're going to circle all of the common factors. So they have 1's in common, they have 2's in common, and 4's in common. They don't have 5, 6, nope. So out of all of them, which one is the greatest common factor that they have? So the greatest common factor would equal 4. Again, we're going to take that greatest common factor 4 and use it to help us out. So I'm going to rewrite this. 20 minus 12 is our numerical expression. So using the greatest common factor 4, what can we multiply to 4 to make 20? Well, 4 times 5 equals 20. Same thing. What can we multiply to 4 to make 12? Well, 4 times 3 equals 12. All right, so there you go. So 4 times 5 equals 20 minus, remember this symbol stays there, minus 4 times 3, okay? Again, we're going to bring that down. So we're going to rewrite this as a distributive property of multiplication. So we're going to rewrite the greatest common factor 4, and then we have 5 minus 3. So when we distribute, 4 times 5 equals 20, okay? And also 4 times negative 3 is going to equal negative 12. So there you go, my friends. You, again, have just factored the numerical expression using the greatest common factor. All right, for this next problem, this next example, we're going to factor algebraic expressions. So we're going to factor the algebraic expression 3x plus 42 using the greatest common factor. So the same concept as last time, okay? So you have two terms. You have the term 3x and you have the term 42. So you have an addition symbol here, the addition operator, the plus sign is what I'm talking about. So you have two terms. 3x is a term and the number 42, the constant, is a term. So from here, you're going to rewrite, 3x and 42. So again, we're looking for the greatest common factor between these two. You may think that the greatest common factor is going to be 3, but it's not. So when we multiply 3x, we're actually doing 3 times x. Now for 42, you can find the greatest common factor of 3x and 42 by writing their prime factorizations. This is what we're doing right now. Now, for 42, we're going to use a factor tree to find the prime factorizations, okay? So in my head, I'm thinking like, all right, what two factors make 42? So I do know that 7 times 6 equals 42. 7's a prime number. 2 times 3 equals 6. So I'm circling all my primes because 42 is a composite number. So I'm going to list all my prime numbers in ascending order, starting with the smallest. 2 times 3 times 7. Okay. So by looking at this, I guess lo and behold, yes, your greatest common factor is 3. So your greatest common factor is 3. I guess I was wrong before, kind of just assumed that. All right, so now we know that the greatest common factor is 3. So we're going to use that to rewrite this algebraic expression. So again, I'm going to rewrite it. 3x plus 42 is going to be equal to, using the greatest common factor, 3 times x, okay? And then that plus sign there, plus 3, and then what can we multiply to 3 to make 42? Let's see. 4, 8, 12, 3, 4. Okay, so that's correct. So 3 times 14 does equal 42. Again, let's go ahead and rewrite this. Your greatest common factor is 3, so we're going to do x plus 14. So there you go, my friends. Again, you wrote the greatest common factor from this algebraic expression and factored the expression. So there you go. So if you multiply 3 times x, you're going to get 3x. If you multiply 3 times positive 14, you're going to get positive 42. So that makes that statement true. Okay. Let's move on to the next one. So for this one, you have 63z minus 27y. Again, there's two terms separated by your subtraction symbol. 63 is the coefficient, z is your variable, negative 27 is your coefficient, and y is your variable. So we're going to factor this algebraic expression using the greatest common factor. So we're going to write the first term 63z, and the second term 27y. Okay. Let's see. Let's break them into primes. So 63 and 27. So I do know that if I take 63 and divide it by 3, 3 is prime times 21, that is going to be 21, and 21's composite. So 21 divided by 3 is going to be 7. And there you go. 7's prime, 3's prime, and 3's prime. So I'm going to write 3 times 3 times 7. And don't forget that z times z. Okay. So there we go. We use all the primes for 63z. And then 27. So we do know that for 27, it is divisible by 3 as well. So 3 times 9 is 27. 3 is prime. And 3 times 3 equals 9. So for this one, I'm going to write 3 times 3 times 3 times y. Okay. So there you go. Now we're going to circle all of the common factors. So it has 3 in common, one set of 3, and another set of 3. So in this case, for your greatest common factor, we're going to put both of these down here. And what's 3 times 3? Well, 3 times 3 equals 9. So your greatest common factor of 63 and 27 is 9. We're going to use that 9 here to help us factor the algebraic expression 63z minus 27y. Okay, so we're going to rewrite it using the greatest common factor. I'm going to rewrite the problem here, 63z minus 27y. So using the greatest common factor, 9. Okay, so what can we multiply to 9 to make 63z? Well, 9 times 7z will equal 63z. Bring down your minus symbol. Now you're thinking in terms of what can I multiply to 9 to make negative 27? Well, let's just start here. 9 times 3 does equal 27, but don't forget your variable y. So 9 times 3y equals 27y. Now we're going to factor here now, okay? So we're going to take that 9 and we're going to put in parentheses 7z minus 3y. Because when we distribute, 9 times 7z is going to equal 63z. And when we distribute, 9 times negative 3y is going to equal negative 27y. So there you go again. And that's really all you do. So again, you do have to remember that you need to brush up on your skills of finding the greatest common factor, and also to write in prime factorization, breaking a composite number into prime numbers, and writing in prime factorization to help you out, especially when you work with algebraic expressions. Okay, so the last thing we're going to work on is modeling real life. So this is going to be a real life situation where we apply everything we've learned from chapter 5. So let's go ahead and read the paragraph here. So I want you to imagine you in real life going through this scenario. Okay, so let's put ourselves in these shoes. All right, so you receive a discount on each book you buy for your electronic reader. It could be a Kindle Fire, it could be a regular Kindle, it could be an iPad, as long as it's an electronic reader. And the original price, each book is X dollars. So we don't know how much each book's cost, but it is the X dollars, the amount. So we buy 5 books for a total of 5X minus $15. we're going to factor this expression, 5x minus $15, and then we're going to conclude about the discount. So, to factor 5x minus 15, you can find the greatest common factor of 5x and 15 by writing their prime factorizations. Okay, so we're going to take the terms. So there's two terms in this algebraic expression. You have 5x is a term and 15 is another term separated by that subtraction sign. You have the constant 15 and the variable x and the coefficient 5. Okay, so we're going to take 5x, the first term 5x, and we're going to write the second term 15. Again, we're going to write the prime factorizations of these numbers. So to make 5x, we're going to multiply 5 times x, and to make 15, here's 15 using the factor tree. So find a prime factorization of 15. 3 times 5 equals 15. So 5 times 3. Now, what did they have in common? So we're looking for the greatest common factor that 5 and 15 have in common. Well, the only thing they have in common is 5, so the greatest common factor is 5. Now, we're going to write the greatest common factor of 5x and 15. So we have the greatest common factor 5. We're going to use this greatest common factor to factor the expression. Okay, so the original problem was 5x minus 15. So using the greatest common factor now, I'm going to put 5 here. So what can we multiply to 5 to make 5x? Well, we just multiply that by the variable x. And then the subtraction symbol, I rewrite it here. And then what can we multiply to 5 to make, negative 15? So negative 15. Well, negative 5 times 3 is negative 15. So when we write it as a distributive property, again, the greatest common factor is 5, but what we do inside parentheses is put x minus 3. So when you multiply these, 5 times x is going to be 5, and then distribute 5 times negative 3 is going to be negative 15. And there you go, my friends. You just wrote the expression, the algebraic expression, and factored them. So remember, we're factoring expressions with 5.5, utilizing everything that we've learned all the way from chapter 1 to now. Okay? So again, hopefully you paid attention. You just didn't log in and left the room. I do highly encourage that you rewatch everything from 5.1 all the way to 5.5 to prepare for the exam. Practice on IXL. Make sure you be ready for that exam that's coming up. Okay, so again, reach out if you need help. We do host tutoring sessions. I'm not seeing a lot of you guys. I really wish you guys took advantage of it and catch up. Okay, so progress reports are going to be going out this week, Friday, March 12th, and please be ready. Okay. All right, so that's about it, guys. And so again, just to recap for 5.5 factoring expressions, by now you should be able to use the distributive property to factor numerical expressions. You should also be able to identify the greatest common factor of terms, including variables. You should also use, by now, the distributive property to factor algebraic expressions, and also understand, that's what interpret means, be able to interpret factored expressions in real life problems. All right, well, again, reach out for help if you need it, and rewatch the videos to refresh yourselves, and just think of the videos as lessons, as me teaching you guys. That's exactly what they're there for, so take advantage of it. All right, ask for help.